Hello and welcome. In this lecture, I want to talk about the include statement. And so again, from our first challenge, our first exposure to C code, a C program, you should have noticed this include statement. It's on line 8 here in this example, and this is our example challenge project, basic C program. You see it's include. And now, because we've learned about the preprocessor, we know that it's a preprocessor directive because we have that pound symbol. Anything that starts with the pound symbol before any other spaces is a preprocessor command, a preprocessor directive. And so we know line 8, include, special keyword with the pound symbol is a preprocessor directive. I now want to explain to you what exactly this is doing. What does this mean? Again, this is a basic concept in C that we need to talk about very early on because every C program has it. It's very similar if you're familiar with Java with the import statement. But we're going to describe this in detail now in some slides, but you'll see this in all of your C programs. So the include statement is a preprocessor directive because of that pound symbol. We know that. And we call it a statement as opposed to a directive for no real reason, just because it's common to use that term in programming language. But it is a directive technically. And again, the example in our program was including this something in these angle brackets. So we see this include keyword, and then we see this stdio.h. And so this is an example, and this is the one that we used in our first challenge. It is not strictly part of the executable program. However, the program won't work without it. We know it's a preprocessor directive. It doesn't really do much as far as how the program works. It's just telling the compiler before it runs, hey, we're doing something here with this include. And so if you don't have it there, the compiler is going to complain and throw errors. So you need it. The pound symbol indicates that it's a preprocessing directive. We talked about that, which is an instruction to your compiler to do something before compiling the source code. There are many, many preprocessing directives, and we gave some examples in our preprocessing lecture. We talked about constants, defined statements. We talked about if and else and so forth, the conditional preprocessing directives. But this is one of the most really commonly used ones, the include. And so, again, these directives can be anywhere in your source code, but they're usually at the top. And the include specifically, this include preprocessor directive is very similar to the import statement in Java, if you're familiar with that. But what does that mean? So in the above example here with the include pound symbol stud stdio.h, this is telling your compiler to include some of your program contents of the file with that name. So there's a file name that exists somewhere called stdio.h. And what the directive is saying is, my current program that contains the directive needs some of the contents inside this file in order to compile. So specifically, the include directive is going to have file names that end in .h. These are called header files. They're called header files because they're usually included at the top of the source file. It's one of the first things you do is you include all your header files. And again, this preprocessor directive is saying, I want some of the code, some of the contents inside that file. It's not a C file. We know that files that end in a .c are C source files. So the .h has to be something else. And it is. It's a header file. And it has that .h extension. So let's talk about what a header file is. Header files define information about some of the functions that are provided by that file. And I'll give you an example of some of the content in a header file. But first off, they're defining some information about some source code. And specifically for our example with that included stdio.h, this is including a C standard library header. So remember I told you about libraries. Libraries are just additional functionality that's already written for you in C that you can include in your program so you don't have to rewrite it. So again, examples of libraries are, reading and writing to the console, displaying output, reading and writing files, all sorts of different things, doing networking code, many, many different libraries out there. But stdio.h is a C standard library. What that means is it comes with the C programming language. And it provides functionality for displaying output, among many, many other things. So stdio.h, it's a header file. It defines some functionality that the compiler needs to understand before it can actually use it. So specifically, stdio.h contains information about printf. And so we're going to talk about printf in the next lecture, which helps us display output. But printf is a function that's in the stdio.h header file. And it also contains many other functions. stdio is short for standard input output. So this library is contains functionality for dealing with input and output. And so this is the concept of using a meaningful name. We don't want to call that library JSON or JSON.h because that's not meaningful. We use std.h because it's saying standard IO, standard input and output. And we know that that library contains all sorts of functionality for input and output. Specifically, the functionality that we want to use in our challenge program, our example first program, is we want to use this function called printf, which allows us to display output to the console. And so by including this stdio.h in our source code, we're saying in order to compile, in order to use this functionality, this printf, we need to include this file. So header files are going to specify information that the compiler uses to integrate and utilize any reuse code, any functions within a program. So you're going to either use many different standard library header files, and there's many out there. stdio.h is just one. There's again header files that define functionality or function prototypes for networking code, socket code. Again, we're going to go through a lot of them. Strings for complete words and things like that. But in addition to the C standard library and in the different libraries that come with the C programming language, you can also create your own header files, and you will be creating your own header files because header files allow for software reuse. They allow you to reuse functionality written in C. So somewhere, the designers of C wrote all this C code that reads and writes data and handles input and output. They don't want this new C programmer to have to write their own, so they're going to write it for you, and they're going to say you can use it. And the way that you use it is you include the header file. And so you, as your own developer, you may write some code in a big, large program, thousands of files that you want to be used in other files. And so you'll write your own header files. And the header files, again, are going to define function prototypes, different constants, all sorts of different things that are going to help another file that can use your program. It will help compile your program. So it's a software reuse technique essentially. So we're going to include this standard io.header file in a program whenever we need to use the printf function from the standard library. It's required. If you didn't include it, it will not compile. So whenever you're using certain functionality, you have to use the include. The syntax, as far as header files go, they are case sensitive. Case sensitivity means uppercase or lowercase. It matters whether you do one or the other. So you should always write them in lowercase. Your header files should be in lowercase, because otherwise certain systems may interpret them as different, have a different meaning. There's two ways to include header files in a program. You can use angle brackets, such as #include JSON.h in angle brackets. And what this usually means is it's telling the preprocessor to look for a file in some kind of system directory. It's usually a standard library that comes with the C programming language. You can also use double quotes. Double quotes usually means it's a user-defined header file. It's one that you created as a developer that didn't come with the C programming language, but you want to have that header there because you want to reuse some code. So it's also going to say look in the current directory. Every C compiler that conforms to the C11 standard will have a set of standard header files supplied with it. These are just header files that represent libraries. C functionality that comes with the language. You can also, when you do use the include directive, it's common practice to use the other preprocessor directives, if not define and define, so that you don't include the file more than once. This is for efficiency. So if your program is using printf, for example, displaying output to the screen, you want to tell your program, hey, I need to include this additional functionality in the standard library. You don't want to tell it to include it more than once because it becomes, the preprocessor will do many things that it doesn't need to do. So typically you'll use if not defined. So you'll see some of this in some of the examples that I provide where I wrap the includes in these if not defines and define statements. Here's an example of a header file and its contents. You may have some header file, has some comments in it. It could have other things in it. It mainly has function prototypes in it, but it can have constants. It can have type defs. These are some concepts that we don't understand yet, but I'm just trying to illustrate, trying to help you understand that it contains many different things. But again, for our standard library inclusion, standard io.h, there's something in there called printf that defines the printf function so that when we link, we can find the implementation code for that. So here are some function prototypes. Function prototypes are just names of functions. We know what a function is, hopefully by now. It's just a way of grouping code together. We'll talk about functions in much more detail later. So a header file can include many, many different things. It can include defined directives, constants, structure declarations. This is, again, kind of a way to group different variables, group different data. Typedef statements have to do with data types. We'll talk more about that. But function prototypes are really the important one. They're telling you how functions are defined so the compiler can generate the code it needs to. Executable code, remember, goes in a source code file. A source code file ends in the .c extension. Executable code normally doesn't go in a header file. There are some exceptions when you want to do things inline, which is, again, an efficiency thing where you can put source code in header files. But typically a .h file, a header file, is not going to contain implementation code. It's going to contain lines of code for just definitions. All right, there's not going to be any logic in there. It's just going to be definitions. This function exists. That function exists. These constants exist. These different structures exist. They don't say how this code is doing what it's doing. It's just telling you that it's there. It's needed by the compiler to generate the linking. Okay, so you're going to create your own header files. You're going to use system header files for additional functionality. It's a concept that you need to understand before you move on with writing C programs, because you're going to see this include directive in all programs. And it's just telling the program, again, that we're including an additional code somewhere. We're including additional definition code so that we can now invoke these different functions and this different code in our C program. So I hope that makes sense. It's not a real complicated concept. We're including additional code. It's pretty intuitive, but we'll go through it and we'll provide more examples as we go. Thank you.